Okay, so in 11.2 we're going to be looking at some of the calculus with parametrically defined curves. So on number 8 we have a parametrically defined curve here, and the question is to find the tangent line at t equals 3. Well, in order to find the tangent line at t equals 3, let's figure out what we need. We need to maybe go back and remember some Calc 1, where what we did was we said we have a slope at a point, and then we use point slope form to find the tangent line. So basically what we need is to find those two things. So in order to get our point, that's the easy part. So let's start with that. Our point that we're going to work with in terms of x, y, if t is 3, then x is going to be negative, and then the square root of 3 plus 1, so plug 3 into your t's here. So we're going to get negative square root of 4, so negative 2, and then our y value is square root of 3 times t, so square root of 9, which is 3. So the point that we're working with is going to be negative 2 and 3. So that's one big piece. The slope. We have been defining the slope of a line as the derivative of the graph at that point. Well, the derivative is dy dx. It's kind of problematic when we have x in terms of t and y in terms of t, because if we were just to take the derivative of x here, that derivative is in terms of t. If we take the derivative of y, that derivative is in terms of t. But we can use that with the parametrically defined ones, because they are defined in terms of t, and they both are that way. The derivative of your function y is a derivative of y with respect to t, and the derivative of x is also with respect to t. So it turns out that if we find both of those, with the derivative notation anyway, dt's cancel, which will give us a dy dx. So what we need to do is we need to find dy dt and put that at over dx dt. So let's look at y. Y was square root of 3t. So we need to find the derivative of y with respect to t. So that'll be a half times the square root on the bottom. And then don't forget your chain rule, so times the derivative of 3t, which is 3. And then let's go ahead and find this at t equals 3, because we know where we're working at, so we might as well plug that in. So we have 3 halves, and then we have 3 times 3 in the bottom, so we'll have 3 over 2 times 3, which is a half. So dy dt at t equals 3 is a half. So this is actually going to be the slope at t equals 3, because I'm going to go ahead and plug in my 3 as I go along. Okay, now x, our function x that they gave us, was negative square root of t plus 1. So if we find the derivative with respect to t, we'll have negative, and then we have a half, and then times that square root again in the bottom, and then by chain multiply by square root of, or multiply by derivative of t plus 1, which is 1. So we are done with that then. So, oops, dx dt. So let's calculate that at 3. So we have negative 1 half, and then square root of 3 plus 1 in the bottom. So negative 1 over 2 times 2, which is negative 1/4. So we get negative 1 half over negative 1/4, which should reduce down to negative 2. So now we have our slope, and I will finish finding the tangent in the next video.